Hello, my name is Brenton Bostic. This talk is going to be an overview of code tools. And I know not everyone here is familiar with what code tools is, so I'll go over that a little bit. But after that, mainly showing a lot of stuff in action, though. So the main thing I wanted to show today was how easy it is to set up using Visual Studio Code to develop Wolfram Language code. And then everything after this is going to be icing on the cake. So the rest of the goals. As a background, Code Tools is a suite of software for symbolically working with Wolfram Language code, and other editors and IDEs can harness this through a standard published by Microsoft called LSP, short for Language Server Protocol, and people can look all this up. So in several versions now, you can work with code symbolically. So you can see this is a string of code, and you can do functions like parse it and get a big tree thing back. You can summarize the problems with the code. Oh, look, I have an extra underscore there. You can format it. Hey, look, probably want to put a new line after the set delayed. So stuff like this. And then the whole point is to take all of this and plug it into Visual Studio Code and make it even easier to use than what you see on screen here. So I've given talks in the past at WTC, and obviously you don't have to know the links to all of these, but they are up on YouTube. So all of these, and there's been a blog put out. And there's another talk immediately after this in the same room given by the same speaker, instrumenting Wolfram Language code. And it's going to be a lot of new stuff too. So building on everything that I'm going to be talking about here. So, all right. So Visual Studio Code it's a free IDE. You can download it, install it. It's available on Mac, Windows, and Linux. Go here. I already have it installed. I'm not going to do that, but I'm going to start it up though. And I'm going to hope I can, kind of make things bigger. Kind of a lag there. Kind of probably good, fine looking. So I have some stuff that looks like Wolfram Language code, but nothing's really that spectacular looking yet. And you can see down here on the right, in the corner, it's just plain text. So this is the stock experience that you get with Visual Studio Code, so not very exciting. So all that you have to do is go over here on the left, click on extensions, type in Wolfram. So you're gonna get a lot of results. There's only one with a blue check mark though, and that's us. So just click install. That's installing there. And then give it a second because things always take a second to pop up. That's how easy it is to get Wolfram Language development working in Visual Studio Code. So I guess I could be taking questions now if anybody has any questions so far, but otherwise I'm going to just keep going. So if you have an installation in a non-standard location, you'll have to go in and change things, obviously, but this is what can work just out of the box. So also not going to be going into detail about how to use Visual Studio Code right now. But so anyway, there are lots of nice features that you get with Visual Studio Code and the extension. So one, you probably see all the coloring popped up. That's very nice. Things that are functions and built in are recognized. Things that are not recognized are not colored the same way. Some things you probably should not have in package code, but whatever, do you. But mainly, a bunch of squiggly lines just popped up. And these are all little warnings, like stop using for loops, use table instead. And you're using confirm without using enclose, and all sorts of things. You probably didn't mean to have this ampersand here after that function. So all of this stuff just pops up. And so you can see me typing. I can't type to even give it the wrong. So it's interactive. You don't have to do anything. Things will just show and get underlined as you type. And so there's no really faster way of fixing bugs than immediately after you just made the bug. So that's the name of the game here. So, this is just another example, but all of these are all interactive. Some are a little bit more pedantic than others. Don't put space between equals and dot. It's documented. But yeah, please.
So I assume red squiggle means pretty serious, and yellow squiggle means warning of some kind.
Yeah.
What's blue squiggle?
Yeah, it's a remark. It's like blue, like stop using for loops, abbreviated string patterns. Like you're using an asterisk, like the old string matching, like asterisks and @ signs. Like you probably didn't mean to do. You may have meant to. A lot of this is associated with the confidence that this is actually a problem. Everything in here is perfectly valid code because there are no syntax errors, but you probably meant to do this on line 88 a lot less than you meant to do this on line 80. So yeah, so there's a big part of that. So yeah, there is a certain level of subjectivity involved, yes. One man's remark is another man's error, I suppose, but yes. So if you're just getting it, it doesn't really matter what they are. You can crank down the confidence level, and I've done that to show everything here. At the end of the day, it may not really matter like what the severity is, as long as you see something. Oh yeah, another question.
So yesterday, some of the themes that kind of came across when Steve was talking, trying to get in the hands of more people using it, etc. So there's a lot of programmers on the planet. Lots and lots of people are developing stuff not in Wolfram.
Yep.
I'm wondering if this is like the first step in perhaps many steps to sort of like get the Wolfram environment more in line with this thing called, DevSecOps, DevOps, development of code. Those programmers are largely developing code in an environment in which they have to run their code through lots and lots of steps, lots of different tools to make sure that the code is not going to break somebody.
Yeah, sure. I'm not really sure. We can definitely talk afterwards. But yeah, this could definitely be the first step in this process that you're talking about. We can talk more. We can talk more after. So yeah, so hovering and outline. Yeah, so you can see you get the documentation. If you switch over to the file editor, you can see that there's an outline. This file is not very exciting. It has one function definition, but so there's an outline and all of this stuff. So it's all very, it's trying to just make everything so much easier for you to write correct, good code. So that's that. That's, so use Visual Studio Code if you want, but also all of this equally applies to other editors that support Language Server Protocol. Sublime Text being the other huge one. And I think I may probably even have it running. So, and then it kind of falls off. Those are the two big ones, but others, I don't even know what the third one would be, but yeah, so give it a try, see if you like it. It'll probably make your life much, 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 much easier if you have found that you need, this kind of solution. So cool. All right, so that's that. I also wanted to talk about recent updates too. Yeah, I already actually have the same file open. So just quickly can go over some of the updates to Code Inspector. So some of these are a little bit more obscure than others, but if you're doing a string expression, you probably didn't mean to have implicit times, and so you probably forgot the tildes there. If you have a string expression in a match queue, you probably meant string match queue, so that let's just fix that, oh, look, now it's fixed. So you get a lot of these, you have replacements built in. What am I saying here? Oh yeah, you have the extra, yeah. You probably, if everyone can see, you probably did not mean to have the underscores kind of like being hidden by the squiggly line. Ironic. But yeah, underscore colon, you probably just meant to have the one. So So that's warning there. A lot of this can happen when you're refactoring. Oh, I want to change the ampersand to spelling out function, and then you like forget to delete the ampersand. So yeah. So these are all kind of just new since 13.1. String join, you probably meant string expression. That any use of non-commutative multiply is probably an error in my experience. You probably just meant times. So perfectly allowed to do it, but you probably didn't mean to. Yeah, the old style, ampersand, @ sign, and asterisk string matching. If you don't even know what I'm talking about, then that's fine. Confusing select in cases also happens. You meant to have select here or vice versa, that kind of thing. You meant to have rule delayed instead of set delayed. You meant to actually have ampersand here instead of just ampersand. Like all of this is perfectly valid syntax in Wolfram language. So yeah, similar kind of thing. And then, kind of forgot one, and that's all goofy. Then a very recent thing is if you do anything with export packet, stop doing that and use front end backtick export packet in recent versions. Yeah, so anyway, yeah. Those are all just recent additions. And so there are Packlet updates that just get pushed out every so often. And you just get all of this updated for free. Yeah, so for code analysis. But all of that's just been in Visual Studio Code so far. I can show what has been added to the notebook front end as well. Yeah, okay, good. So everything's working. So I'm going to tempt fate and just analyze the entire notebook. I know I have dynamics, but actually I don't think it matters. Anyway, yeah. So you can see all of the, I don't think I can zoom in. Yeah, the code analysis pop-up thing doesn't zoom in, but these are all the same warnings, but in notebook code. And so for people that aren't aware, there is this menu item on the context menu, analyze cell, and these menu items here in the evaluation menu that you can just run to analyze your code in your notebook. So, analyze early, analyze often. So that these are all the same kinds of things I was just showing. So cool. Yep. Yep. Did you have a question? Yep. Yeah. So a lot of times people don't actually want everything to always be turned on. And so there you can set up ignoring certain issues, and you can, and not through this interface, but it's all programmatic. And I could definitely talk about, after this, how to do that. But yeah, it's all just pattern based. It's actually very easy to add custom rules, just not in this talk right now. But yeah. So this is good notebook code analysis in notebooks. So use it. And so something bleeding edge that I've been working, a lot of people have been working on. I'm going to copy. Zoom in again, even though probably won't. So I think Stephen showed, there's a little guy right there that says analyze input for issues. And so I evaluate this and you get a message. And Stephen was talking about this a little bit last night. Given that you already evaluated some code, it seems like you should be able to use that information to get even more power with the analysis that you want to do. And so this is the beginning of using the fact that you have messages and even the actual runtime, the actual stack, that is stored with the message to do a little bit more. And so what this is, I'm going to click on Analyze Input for Issues, and it'll take a second. And what this is, it's very basic. It's just basically talking about what the message itself is saying. So maybe not very exciting, but this is completely contrived, but I accidentally put in chessboard distance when I shouldn't have, but it's telling you exactly where the error is. And you can imagine in a huge page of code, it would be a lot harder to pinpoint it than on this single line example, but this is all for demonstration purposes. But yeah, so that's that. And then similarly, you can see that it's underlining the part that it's talking about. And so I've been going through a process of kind of semantically analyzing the text of messages for when they talk about position one or, you know, option blah of this function. So to be able to have this knowledge. And so, but yeah, this is the beginning. And I hope to be able to do more analysis for this kind of stuff in the future of not just talking about the same thing that the message itself is talking about too. So yeah, kind of useful nonetheless already though, I think. So yeah, so any other questions? Yeah, cool.
There where you say ampersand, maybe should be ampersand, ampersand.
No, and yeah.
Do you make any attempt to distinguish between that case and the case where you might want an at or a slash at there? Because that's much more common to me. I put in the ampersand, but I forget to add the slash at.
That's true. I mean, adding another suggestion about what to do could be, I mean, yeah, that's a good point. If somebody could write that down and remember to tell me that afterwards. Yeah, I mean, just adding more suggestions like that, like of what the common cases, you know, is just the name of the game. So yeah, I mean, yeah, definitely. Right. So since there's still some time, I'm going to just kind of go through some more fun, goofy stuff, possibly. What does Wolfram language code actually look like? Here's some random code that I just grabbed, and I parse it, and I use Ian Ford's tree stuff to actually visualize it. So you can easily just visualize this as, you know, that this tree, this expression that I'm not going to show is huge, but you know, this is the structure of it. It's like, well, okay, that's pretty cool, but the goal of CodeParser is also to be able to always speak intelligently about even handling syntax errors. Given any input, CodeParser is going to give you something. It's not going to just stop and say, I can't do this. So you could almost imagine using, like, what do other programming languages look like if they were treated as Wolfram language? And so, you know, here's some just random Perl code. It's not Wolfram language, but some operators, you know, there's an @ sign and, you know, whatever. Like, what does that look like? So parse this, and, you know, you get something back. So, you know, kind of interesting, maybe not, I don't know. I thought it was interesting. And then similarly, you know, PDF, you know, PostScript looking stuff, you know, that's get, right? And that's put, and this is divide something, you know, this is Wolfram language code, right? I mean, something, it means something. And you can see like what the structure is. I wonder if like something got slurped up in some big string, like there's a lot less, there's more structure here than I would have thought this is showing, but yeah. So, you know, there's some goofy, you know, symbols, you know, and all that's fine. So anyway, I thought that was kind of interesting. Right, so yeah, 5 till.
What would the tree show for the actual syntax error? So like it's 1+. What would you see in the tree?
Yeah, so I can just even show. So it always says something. I can just. So what it does here, instead of a leaf node that is always included for tokens, it's just another made up thing like error node, but it's not displayed in any other different way. So this is still just a tree, you know, as if like it's still that there is something there. It's made up, but, you know, so same thing. So, but yeah, cool. All right. Any other? Yes. Well, it does the best it can. I mean, it's not going to, yeah. There are lots of things that can go wrong. And at the sign of slightest trouble, it just gives up. I mean, nothing, it's not going to go to like Herculean efforts to try to like decrypt and, you know, decode anything that it, you know, that it shouldn't be. So, but yeah, I mean, if it can make an unambiguous, if it knows where the message came from, even depending on where the code is, because you might have some code that's protected here, but the code at the top might be not encoded and the code at the bottom might not be encoded, and you still might be able to say something, like if you're not talking about the actual protected code. So yeah, I mean, it just depends. Yeah. But, all right, cool. Well, thank you. Instrumentation talk is immediately following this in a couple of minutes. So thank you.